Dear students, how are you? Hopefully you are well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about circle. Especially we will looking for some problem solution on the circle related theorem. Because today we are trying to solve two CQs, and especially CQ is very important for your exam. Generally, we have observed that these types of CQ has come in your SSC or the board exam directly. So this part are very important for your upcoming exam too. So let's start our today's class. Students, how are you? Hopefully you are well. This is your lecture number 4, and in this lecture we are going to talk about some CQs, and where our first CQ is related to our theorem of circle is CQ number 5. Okay, the statement is given, that is stream actually. Stream is given. Stream is O be the center. O is the center of this circle and with radius 2.5. What is the radius of this circle? Radius can be OA, OD and OB. These all are the radius. AB is 3. AB is 3 is given. Suppose we are thinking that our radius is 2.5, that is these two are 2.5, and BD is the bisector of ADC. Okay, so these two parts are very important for our first question. Our first question says find the length of AD. We have to find the length of the AD side. So how we can solve for these questions? Solutions. Here we can say that OB is the radius. So here there is given the radius is 2.5 centimeter. So here we are thinking that our radius should be OB. It's our assumption that this is OB. So what about BD? So BD should be 2 into OB, or 2.5 plus 2.5, because these two are all the radius. So OD plus OB, that is 2.5 plus 2.5 centimeter, and that is equals to 5 centimeter. Okay, so now we are going for our main part. So this is 5, this is 3, and we need to find the value of AD. Since this is the biggest side, that's why we can say that in this triangle, this is a right angle triangle where this is the hypotenuse. So we know from the Pythagoras theorem that hypotenuse square is equals to base square plus height square. So we are going for that formula. Okay, now from the Pythagoras theorem we can say that BD square, that is the hypotenuse, equal base, that is AB square plus AD square, and here AD should be find out, that's why we can write AD square equals to BD square minus AB square, and we know that BD was 5 square minus 3 square, so 25 minus 9, where it was AD, and now it should be AD, here will be root over, so it can be written as root over 16, that is 4. So this side is 4. Since all of these are centimeter, that's why this will be our also centimeter. That's how we can solve this types of very easy math. Now we move on to our second question. Okay, our second question is show that ADC plus ABC is equals to 180 degree. That means here ADC is this angle and ABC is this angle. So we have to prove that these two angles summation is 180 degree. We have to prove. So now what will be our special nomination or the proposition? It can be said that, let us assume that ABCD is a quadrilateral having center O. So ABCD is a quadrilateral having center O. This can be the ABCD is a quadrilateral having center O. That can be the spatial nomination, and we have to prove that it is already given that proof that what angle ADC plus ABC is equals to 180 degree. And there is a construction part also. The construction part can be we have to add AO as well as OC should be join. So join OC. This is our construction part. Now our proof part. Proof part is very interesting from this theorem, because we know a formula that central angle always ties than the inscribed angle, or inscribed angle is half of the central angle. We'll use that statement. So we can write from that statement that if we are thinking ABC arc, on arc ABC, then this angle is equals to 2 into that angle, that is angle of AOB is equals to 2 into ADC. This is number 1. On arc ADC, it can be written as that angle. It is reflex AOB, because when we are going for this AOC, sorry, it should be AOC. AOC, that is the central angle is 2 into ADC. Then our reflex, since we are thinking for this angle, that's why we have to think about the reflex. Okay, so reflex AOC is equals to 2 into ABC. Okay, now adding these two theorem or these two equation, if we are adding these two, so from 1 plus 2 we get actually AOC plus reflex AOC is equals to 2. If we are taking common, then ADC plus ABC, ADC plus ABC. So but we can see from this figure that this angle plus this angle, that means our total circle. We know that total angle is 360 degree. That's why but angle AOC plus reflex AOC is equals to 360 degree. Then we can say that our this part is equals to actually 360 degree, that is 2 into ADC plus ABC is equals to 360 degree. Since it is 2 into this is 360 degree, so what about this? It should be divided by 2, that means 180 degree. So ADC plus ABC is equals to 180 degree, and that is our required root. Clear? So we are just using one formula only, that is the central angle is twice than the inscribed angle, or inscribed angle is twice than the central angle. Clear? Okay, dear students, now we are thinking about question number 3, and for this theorem or this part, if we are trying to solve, then this statement will be very efficient for this theorem too. This statement is BD is the bisector of ADC. If BD is bisector of ADC, then what can be said was, then we can say this equals to, that means this angle equals to this angle, this angle equals to this angle. If we are just using this concept, then we can easily prove this theorem. Okay, spatial nomination is similar, that suppose spatial nomination can be written as what, ABC is a quadrilateral having center O. It can be written, then we have to prove that what AB equal to BC, and no construction needed. We are just going for the proof part. Directly we have the proof part, and in this proof part what we can say? We can say that since BD is the bisector of ADC, since BD is the bisector of ADC angle, then we can say that angle ADB is equals to angle BDC. Okay, if these two are equal, then we can say these two will be equal on that time if the arc of this and this are equal, if this arc are equal. So we are just trying to focus on the arc of AB is equals to arc of BC, arc of AB equals to arc of BC, because on this arc this angle are actually remaining, and on this arc this angle are remaining. In these types of statement we have been just proved earlier. So if these two arcs are equal, then we can say that these two sides are also equal. So AB is equals to BC, hence proved. Clear? Okay, dear students, this is our CQ number 2, and in this CQ we are talking about CQ number 5 exactly again, but the fact is we are going for chapter 8.4, and in this time there is a stream is given, and stream says PA and PB are two tangents. It should be tangents from the point P, external to the center with the center of O. Okay, the fact is we have to draw a figure with the help of this stream. So here is given PA and PB are two tangents. So these two are the tangents with the center having center O. So this is a circle which center is O, and PA and PB are two what, tangent, and we have to just draw this. So this is the number 1 question. Okay, dear students, this is our question number 2 of this actually CQ. Here we have to prove that PA is equals to PB. What actually talking about, that is two tangent should be equal, we have to show. So how we can go for this part? This is the theorem, and first of all we have to go for the proposition part of the spatial nomination part. Spatial nomination can be written as that suppose P is a point which is outside the circle having center O. P is the point which is outside the circle having center O, and this circle can be, you will be denoted that ABC is the circle having center O, P is a point outside this circle, and PA and PB are two what, tangent. Okay, and we have to prove that PA equals to PB. Now let's go for the construction part. Construction part, here we have to join three things, that is OA, OB and OP. We have to join this. So we have to join what, OA, OB and OP. We have to join these three lines. Okay, now our proof part. At the case of proof part, we have to talk about something. Here suppose OB is radius, and here PB is the tangent. Okay, so OB is the radius and PB is the tangent. So which types of relationship between these two? We know that they must have to perpendicular each other. That means they have the angle between 90 degree. So we can write that angle PBO is equals to 90 degree. Similarly, this is the tangent and this is the radius, so this angle is also 90 degree. So PAO is also 90 we have to think so about these two equiangular or the right angle triangle. We have to think about these two right angle triangle since this is the right angle. So from triangle POB and triangle PAO, what we have been found from here, that is PO and PO are same because of the same side. Then here OB equals to OA, OB equals to OA because of the radius of same arc, radius of same what? Radius of same circle. And already we know that this angle is equals to this angle. So we can say these two triangles are congruent. If these two are congruent, then each side and each angle are equal. From that part we can say these two must be equal. So we can write PB is equals to PA, and that is our required proved. Clear? Okay, dear students, this is the last theorem for today's class. In this last theorem, there is talking about what? There is talking about the segment OP. The segment OP is the perpendicular segment OP is the perpendicular bisector of the tangent chord. So we have to actually show that this side and equal, and also these two are 90 degree, because we have to show also this is the perpendicular on, BC is perpendicular on PO and AC is perpendicular on PO also. See, now our proposition part. Our proposition part is what? Let us assume that O is the center having of the circle ABC. O is the center of the circle ABC, where P is a point outside the circle, and from and here we also can say that OB and OA is the radius, and we have to prove that actually BC equal AC. This is the first part we have to prove, and secondly we have to prove PC is perpendicular to what? PC is perpendicular to BC, or AB is perpendicular to PC. These two we have to actually prove. Okay, there is some construction. Construction is join some points, that is join OA, OB, OP, OA, OB, OP. Okay, now we are going for the proof part. When we are thinking for the proof part, we can go first proof part, that from 2 we can already say that what? Our PA is equals to PB. Now triangle POB, triangle PBO and triangle PAO. these two were congruent at the first time, isn't it? These two are congruent. That is the first part was. So this and this are congruent. Okay, so these two triangles are congruent. Now we are move on to this small triangle, that is from triangle COB and triangle ACO. What we can write from these two triangles? We can write from these two triangles as OB equal to OA, OB equal to OA because the radius, then OC equal to OC because the same side, and also this angle is equals to this angle. Why? Because these two triangles are congruent and also these sides are equal. That's why we can say that our angle PBO or POB is equals to POA. Since that two was congruent, then we can say this two was also equal. Since these two angles were equal, that's why we can say again that here OB is this is this, and the angle is also equal. If the angle is also equal, then these two triangles are congruent now. So if these two triangles are congruent, then we can say that these two sides must be equal. That is so, or therefore CB equal to AC. CB equals to AC. Now we have to prove that these two angles are also equal, or these two angles must be what? 90 and 90, that means 180. Okay, for that part what we can say? So here since these two sides are equal, then our first proof is here, and second part is since these two are congruent, then we can say this angle and this angle are equal, that is BCO is equals to ACO. These two are equal. If these two angles are equal, then we can say but the summation of these two angles BCO plus ACO is 180 degree, or these two makes an straight angle. If these two makes an straight angle, and since these two are equal, then we can say these two nothing but the 90 degree. So BCO is equals to 90 degree and ACO is also 90 degree. Since these two are 90 degree, then we can say that this AB is perpendicular on BC. That was what we actually wanted to prove. That is how we can prove this theorem very easily. Dear students, actually you have to have practice more and more. If you practice more, then these types of theorem will be very easy. You have to make the concept clear to actually to make a good result at the case of theorem. Thank you. Best of luck.